Okay, so just going through those few examples that I didn't do in the theory video, in case you're looking for more work with this. The half-life of a radioactive isotope is 6.8 years. So that is, we call it T1 half, the half-life. If the activity of the original sample is 4.9 times 10 to the 5 emissions per second, so what is that? That's N0, right? What would be its activity a century later? So that is the total time, okay? Now, I didn't really do this in the other one where I just found N first. You can totally do that. You can also say that N 1/2, yes, to the power of N, but we could also rewrite N as T divided by T1/2. Okay, or you could just find N if you want and keep a bunch of sig digs. Let's do it differently this time. Let's do it all at once in one big calculation. All right, so we actually have everything. We just need to plug in our numbers. We started with, and we want to know how many half-lives have passed so we can know how many times to multiply by 1/2, and we're going to have to do it the total time divided by how long is a half-life, 6.8 years. 2 sig digs, I got that that's 18 emissions per second. Okay, now ask yourself, does that make sense? You don't have to be a robot. Think about it, okay? Is 100 very many half-lives? Well, yeah, it's quite a few, right? It's like not quite 20, but approaching 20, right? 20 half-lives. So we're going to divide by 20 times. Yeah, that's going to be pretty small, right? It's going to be a lot smaller than what we started with. So I'm feeling pretty good about that. And you can always check your work, right? If the half-life of an isotope is 3 days, so that's what percentage of the isotope remains after 2.5 days. So that's the total time. So what percentage do we start with? Well, 100%, right? We're saying whatever we start with, we're starting with 100% of it. It's up to us. So even just thinking ahead, make predictions. That will help you be more confident in your work. Has a full half-life gone by? No. So will we have divided by a half? Will we have 50% or less as our answer? No, right? We should have more than 50% as our answer because a full half-life has not gone by yet. So again, just plug in. And to 2 sig digs I got, you would end up with 56%. Okay, feeling good, right? Because we made that prediction at the beginning that we should have more than 50 because it's not quite a full half-life. And it's pretty close to 50, which is good because 2.5 is decently close to 3, right? So that makes sense. All right, carbon dating is used to determine the age of materials. We knew that. Knowing that carbon-14 has a half-life of 5.73 times 10 to the 3 years, and that carbon-14 activity in living material is 0.23 becquerels per gram, what would be the expected activity of a material that is 1,000 years old? So what is that 1,000 years old? Which variable? Total time, right? They told us the half-life. Okay, now this is a little bit of a thinking about what it means. Carbon-14 in living material is 0.23 becquerels per gram. So is that the original amount or the new amount? Well, fun fact, that's actually how carbon dating works. So your whole life, you might know from bio class, you're absorbing carbon, right? The carbon cycle. You need carbon to survive. In fact, we are carbon-based life, we say. Carbon is the building block of all of our molecules, pretty much. You'll learn in chemistry that that's because carbon has great bonding sites. It's a perfect Lego piece. Look at this, all 3 sciences coming together. Beautiful. Okay, anyway, when you die, you stop absorbing new carbon. So the carbon-14 in you is constantly decaying, but you are constantly replenishing it by eating more. And some of that carbon is going to contain carbon-14. However, when you die, you stop eating carbon. And so now you're not replenishing it, it's just decaying. And so we can use the half-life of carbon-14 to figure out within a few hundred years how long ago something died. Pretty cool. All that is to say is that that is the original amount. Then once they die, we start counting half-lives. And to 2 sig digs I got. So the next time you hear that some ancient site has been discovered and they've carbon dated it, now you know how they did it. They just looked at how much of the carbon-14 was left and said, well, carbon-14 takes this long to disappear. If this much of it is gone, they've been dead for this long. Pretty cool. Okay, last one here. Lead-212 with a half-life of 10.5 hours is spilled in a lab on Monday at noon. The immediate activity is 16 times the legally allowed amount for humans to be exposed to. So we don't know what that unit is, but we know that it's 16 times greater. So after one half-life, how many times greater will it be than the legally allowed amount? Yeah, half of that, 8, right? After another half-life, it'll be 4 times greater. After another half-life, it'll be 2, right? And we can figure out from there. So N naught is, and we want to know when are you allowed back in? When it's 1 times the legal amount, right? That's when you can go in again. So we need to figure out how many half-lives that is. So Start with 16. One half-life goes by, you get 8 times the legal amount. Another half-life goes by, you get 4 times the legal amount. Another half-life goes by, you get 2 times the legal amount. And there we go. That's when we're going to be allowed back in. So how much time is that? Right? So each of those arrows represents one half-life. So in total, we count on our fingers that 4 half-lives have passed. And now we just got to say, okay, if 4 half-lives have gone past, how long is a half-life? Times it by 4. And we know that a half-life is 10.5 hours. So, and you get that the total time that needs to pass before you can go back in there is 42 hours. Be careful. Always make sure you look at what the question asked. It didn't say how long. It said on what day and time. So if it spilled on Monday at noon, Tuesday at noon would be 24 hours. Wednesday at noon would be 48 hours, right? Or another 24 hours. So that's 48 hours now, right? So that's too far. So we go back 6 hours from there. So back 6 hours. And what's 6 hours before noon on Wednesday? It's 6 a.m. on Wednesday. And there's your answer. Okay, that wraps up all the examples for this stuff. Now you can definitely try the topic 3 practice assignment in the agenda or Google Classroom.